Now we're going to look at rational exponents. Rational or fractional exponents are used to denote radicals and powers of a base. So if you see a fractional exponent, that means you have a radical. So in this first example I've got here, if you have a raised to the 1 over n, that means the nth root of a. Whatever's in the denominator is that index. In this one, if you have a raised to the m over n, again, the n is the index, and it goes in the little crook of the elbow there, the radical, and a is raised to whatever's in the numerator. Now, it can be written like this or like this. If you're doing it by hand, this particular method is better because you don't have to worry about taking an nth root of a big number. Some examples, I've got 16 to the 1/2. Notice where the 2 is. That means square root of 16, and that equals 4. Now if I do 16 raised, now if I have a fractional exponent, I need parentheses. And there's my 4, which is the exact same thing as square root of 16. Okay? 32 to the 1/2 is not a perfect square. Remember, if 32 has a perfect square, you've got to split it up. Have that perfect square up front because it gets to come out of the radical. Square root of 16 is 4, but the 2 has to remain on because it's not a perfect square. This is how you remember, simplify a radical. Now 32 to the 3/5. If I was doing it by hand, I would take the 5th root of 32, which I know is 2, then raise it to the 3rd, which would be 8. If I put this in the calculator, 32 raised to the 3/5, so 3 divided by 5, and that will give me my 8. So these are just some examples of fractional exponents. And again, if you see a fractional exponent, that means you have a radical. And whatever is in the denominator, that's going to be the index. Now, all the rules for exponents that we've discussed in the past also apply to expressions using rational exponents. So, I've got some examples. We're going to simplify each expression so that only positive exponents remain. First thing I have to do is distribute, if you remember the power rule, distribute the -3 through to all bases. So I'd have 3 to the -3, a to the, I don't know if I went ahead and multiplied it or just indicated. Let's see. Okay, first I indicated that it's distributed to all. Now, anytime I've got a or a base raised to a power raised to another power, remember we multiply those. So this should give me a -2 here. This should give me a -4. So let's try that bottom one. Let me do 4/3 divide by 3 times -3. I'm going to frac it as if I didn't know it was going to be a fraction or not. And if it's not, it'll come out as an integer. So it's -4. So I think the next thing I did here was distribute through. Now, it says that we have to have only positive exponents. Remember your negatives? If you have a negative exponents, they switch positions. So if you have any negative exponents in the numerator, they'll go to the denominator. And likewise, any negative exponents in the denominator go up. Now, it wasn't until we got 3 to the 3rd that we could actually find that that was 27. But notice b to the -4, when it went to the numerator, became b to the +4. And when a went down, it became a positive. So some of our old rules for exponents. Let's see, let's look at this one. First thing I've got to do is distribute this 2/3 through. That's my first job. This one is just raised to the first power. So if I'm consistent, I'll indicate that I've distributed. Okay, so 5/6 times 2/3, you need to find out what that is. See, that should come out for this m here, that should be m to the 5/9. And this one, that would be n to the -4/3. Let's see if I've got that. Okay. Now, when you have a base raised to a power times same base raised to a power, remember, you add those. So let me get those together, the m's together in the n's. So I'm adding those exponents. So this, now this, I know in another video I told you to do these by hand, but since I'm doing something different here, I'm working and I'm trying to get these simplified as quickly as possible. Go ahead and do them via calculator. And go frac it, and let's see what m becomes. So that should be m to the 11/9. Now if I do 3 divided by 4 minus 4 divided by 3, let's go frac. Okay, so m to the 11/9 and n to the -7/12. But remember, negative exponent, got to move it down to make it positive. So that's the last thing I have to do on this one. So there it is. So you might need to go back and re-look at your rules. So in this one, the 1/2, since it's following this exponent, I've got to distribute it to everybody. So let's see if I've done that. 36 to the 1/2, s to the 1/2, t to the, I haven't multiplied through, but that should give me 1/3 here. See, 36 to the 1/2, that would be 6, s to the 1/2, and t to the 1/3. This would be s to the 1/5 if you multiply, and t to the -1/2. Let's see if we got that. Okay. So now, I could move this up. We've done that before, and then add the exponents. Or I could go ahead and just go t to the 1/3 minus -1/2. Try it a couple of different ways. Now these two I need to subtract. 1/2 minus 1/5. So let's see. So this is my quotient rule, if you remember. Top exponent minus bottom. Now before we had nice integer, actually nice whole numbers, and we knew which way to subtract them. But in this one it might be easier just to go ahead and do the quotient rule, where you take top exponent minus bottom. So if you do 1/2 minus 1/5, let's try that. 1/2 minus 1/5. We'll go frac it. So the s will be to the 3/10, so it'll be where it's supposed to be. Now t to the 1/3, 1 divided by 3, minus a -1 divided by 2. We'll go frac it. Okay, so they're both going to end up with positive exponents, and come on. So I'll have 6 s to the 3/10 and t to the 5/6. Okay, now let's look at this one. These are all the same bases. It's a binomial. Notice it's in parentheses. So I'm going to go 4/3 minus 2/5 minus -1/4. All at one time, using the quotient rule. Let's put this all together. So 4 divided by 3 minus 2 divided by 5 minus a -1 divided by 4. We'll go frac. 71/60. Let's see what I did. Oh, I went ahead and got a common denominator. Who knows? Maybe I just felt like it. But if we did ahead and work this out, let me see what 80 minus 24 plus 15. So I'm going to still end up with 71/60. It looks like it's easier if I go ahead and just use the quotient rule, top exponent minus all the bottom exponents, and then go frac it. So my answer here should be that quantity, a minus 3b raised to the 71/60. Ugh. But that's it. Okay, so you got some problems to do. Thank you.